Hi, the lecture today is about the inverse of Z transform. The inverse of Z transform enables us to extract x of n from x of z. As we learn that's the sequence, x of n, and by Z transform we can find x of z. And if you have x of z, to get x of n, so perform the inverse of Z transform. How to do that? There are three common methods: long division of polynomial, partial fraction, and the inversion integral. In this course, we are going to focus on the first two methods. And today's lectures, we are going to explain how to implement long division of polynomials to find the inverse of Z transform. In long division, x of z should be given as a rational expression and b over a. And let me remind you by the expansion of x of z. It's equal sigma from k minus infinity up to infinity, x of n multiplied by z power minus k. If you expand that series, we'll start from minus infinity. Let's go to k equal minus 2. So you substitute n in minus 2, you get x minus 2. Substitute k minus 2, will be negative 2 times negative will be positive 2. So x minus 2 is 2. The same thing, x minus 1 power z plus x naught. x1 z minus 1, that's where k equal 1. If substitute by k equal 1, be x of 1. Substitute by k equal 1 will be z power minus 1, and so on. So observe that, when you have x, the index of x is negative, the power of z is positive. If you have x of minus 2, you have z power 2. If you have x of 2, it's z power minus negative 2, all right? So that's the expansion of it. So if you can expand x of z in this series, so you can find x of minus 2, x of minus 1, x of 0, x of 1, x of 2, x of 3, and so on. These are the terms of x of n. So you got x of n. Well, let's explain how we do that in an example. That's x of z, and that's the polynomial b of z, and that's the polynomial of a of z. But we said there's a condition. You got to arrange the polynomials in descending order of z. That's okay, b, because it's only one term, so you don't have problem. But look for a, it's not arranged. So if you arrange it, should be like that. X of z should be written. The top part is fine, but the bottom you have to start with the highest order, which is z squared, and then second one minus 3z plus 2. Now we are going to perform the long division on this one. How you do long division is just we did before, long time ago. You can do it like that. Z and you start, put here z squared minus 3z plus 2. And then you divide z by z squared. So it will be equal to z minus 1, because if you multiply z minus 1 by z squared, you get z. Continue, z minus 1 times minus 3z will be minus 3 without z, because this is power 1 and negative 1 be 0, means 1, plus 2 z minus 1. And then what's supposed to do? Change the sign and add. So that will cancel. So what you got here, 3 minus 2z minus 1. All right. Then what next? You divide what you got here by this one. So 3, you will say plus 3, and you multiply z squared by z minus 2. Why? Because if you are going to multiply this term by this term, you get 3. 3 times 1 is equal 3, and z minus 2 times z squared will be z power 0, which is equal 1. That's good. This plus. Multiply by the second term. Plus 3 and minus 3 will be minus 9. Z minus 2 times z1 will be z minus 1. 3 times 2 is equal 6, and z minus 2. and then you change the sign and add. So what you get? Well, you get that cancel. That will be 7 z minus 1 minus 6 z minus 2. All right. Now you take this row and divide it by z squared. 7 by 1 is equal 7. And z minus 1 divided by z2 will be z minus 3. And you start to multiply. 7 times 1 is equal 7, positive, and z minus 3 times z2 will be z minus 1. And I know, I want to get this term to cancel. 7 times minus 3 will be minus 21, z minus 2, plus 14, z minus 3. And you change the sign, and you add. So you got 15, z minus 2, minus 14, z minus 3. And you continue, you divide 15 z minus 2 by z squared. 15 by 1 is equal 15. And z minus 2 divided by z 2, you got z minus 4. And then you start to multiply back. 15 times 1 is equal 15. You will know, you will get this term, positive. 15 times minus 3 will be minus 44. Z minus 3 plus 30 z minus 4. And change the sign and add and get. You can continue. So in this problem, you can continue up to the accuracy that's required from you. If they ask for 4 terms, 5 terms of x of n, whatever, then you can continue. Let's just stop here. So what you got here, the division of this z by this b of z, it's equivalent to x of z. Now I can write x of z in this way. X of z, when you divide it, the result you got here, z minus 1 plus 3 z minus 2, 7 z minus 3 plus 15 z minus 4. That's what you got. You can continue, of course, but that's what you got. What does it mean? Well, if I ask you what is x of 0, x of 0, it should have here nothing. It means z bar 0, which is equal 1. You don't have it here. All right? So what does it mean? It means x of 0 is equal 0. Okay, let me ask you another question. What is the value of x 1? Well, you know, x of 1, if you go back to the series, x of 1, it's the coefficient of z minus 1. Where is z minus 1 here? That's 1, so it's equal 1. What's x of 2? That's the coefficient of z minus 2. That's equal 3. What's x of 3? It's the coefficient of z minus 3, which is equal 7. What's x 4? It's 1, the coefficient of z to the power of minus 4, which is equal to 15. So you can continue and you find, but it depends on how many terms you are asked to find, right? Well, what about if somebody asks you what the value of x minus 2? Well, x of minus 2, that's the coefficient of z2. You don't have it here, all right? You don't have it here. So, because it should be before that. So, it means it's equal 0, all right? So now we can find any terms of the sequence that you're asked for x of n. And of course, if you want to find this using MATLAB, it's very simple. To solve this one, and you should try to do the MATLAB. First of all, you are going to use symbolic tools in MATLAB. So the first thing you will write, that's the first command, you write since. And you're going to use z as a symbol and x capital. Then you go and write the expression for x of z. What do I mean by that? This is the expression of x of z. It is z over all this expression, z over z squared minus 3z plus 2. Let me write it here in MATLAB. You write z divided by z squared, that should be z squared, minus 3 times z plus 2, semicolon. And you are going to use command, very simple, to get write small x equal to, let me write this in black to make it clear. This command called I, z, all one word, z, trans. This command in MATLAB means to find the inverse of z transform. Just write like that. And then between bracket, you want to find the inverse of z transform for what? The capital X here. That you already wrote the expression. Don't put semicolon. And then run the program. You'll find you get the same result. All right? You will get, actually, you will get the closed loop for me. The result, if you did, you will get this x equal to, that's in MATLAB, will get you 2 to the power of n minus 1. It means your result, if you write it in the expression, it means the formula, it's 2 power n minus 1. And you can check. You can check if you are getting the same, substitute by n equals 0, all right, and you will find that you get the same result, okay? All right. Now, maybe you want to do in MATLAB different command. There are other command, but just I give you this one because it's easy to perform in MATLAB and check your answer. I hope that was easy. And in the second lecture, we're going to